We're looking at impulse. In order to define what impulse is, we have to look at the pieces that work together to become impulse. So let's take a look at our simulation environment. Here's our impulse environment. What we have here is a mass that is 2.5 kilograms. That mass is then being sped up by this little force here. This little force is worth 1 Newton. So the net force acting on this is 1 Newton. We are going to speed this up until it gets to 5 meters per second from rest. So here's our first trial. So we're waiting for the graph to get to 5 meters per second. I will run this. You can see as we look at velocity in the x direction versus time, we're going to get to 5 meters per second. And it's speeding up faster and faster. There's 5 meters per second. Now, here's your data point. It took 12.5 seconds to get to 5 meters per second from rest. So our change in velocity is 5 meters per second. And our total time that it took was 12.5 seconds. We're now going to reset and do our next data point. Our next data point is, let's double that force to 2. How much time do you think it will take? Go ahead and make your prediction now. Let's see what happens when we let it be 2 newtons. You see our net force is 2 newtons now, and we let it go. What do you notice about the graph of velocity versus time? Note, this is not position versus time. This is velocity versus time. There is our point. So we want to know when it reaches 5 meters per second, it took 6.25 seconds. There's your second data point. Now let's go back and do this again at 4 newtons. 4 newtons of net force acting on this 2.5 kilogram mass. Let's see how long does it take to get to 5 meters per second from 0. This one we're going to have to estimate. We'll round to 3-digit significance. That's pretty good. 5 meters per second in 3.12 seconds. Now we're going to try 8 newtons. Here we go. And it's very quickly gets there. 5 meters per second in 1.56 seconds, 8 newtons. Lastly, I'm going to do 16 to get 5 good data points. 16 newtons. All right. We're already 10 times as much as we want. We're getting close to our item here. So I'm going to go ahead and rewind this. 16 newtons of net force. How long does it take to go from 0 to 5 meters per second? Here we go. Whoops. We need to rewind that. We are already going. I forgot to rewind it. 16 newtons of force from rest. Go. Boom. We hit it already. There's 5 meters per second in a fraction of the time. In 7.78 seconds, it's going 5 meters per second. There's your next data point. So far, we have 1, 2, 3, 4, 5 data points. That's going to have to be enough for now, so we can find out what the relationship between how much time it takes versus how much force we're pushing to go the same mass, the same change in velocity.